SeniMal ya. SeniMal karena emang untuk profesional net zero healthy building design ini difokuskan kepada tempat di mana orang bisa berkumpul dan juga mengapresiasi sebuah karya. Dan yang satu ini namanya SeniMal, terdiri dari Vionda Kokarkin dan juga ada Darmawan Winaga dan juga ditemani dengan please welcome, this is SeniMal.
Okay, good afternoon, ladies and gentlemen. So we're a team for SeniMal. Mungkin bisa langsung next slide dulu. So this is our team. We're all three of us is a professional program for architect of 2020 graduate. First of all, it's myself. I'm Fiona Gokargin. Next to me is Amanite Jiwongso, and on my furthest left is Darmawan Winaga. So in this occasion, we would like to present our design that is called SeniMal. Next, please. So the first question is, why are we designing this? So why are NZHB healthy buildings crucial in Indonesia? So the basic answer is actually that it's no longer an option. With all the crisis happening, global warming, especially pandemic, it is now becoming more important, and therefore designing an NZHB building, healthy building, is becoming a challenge and no longer an option. Next. So first of all, we can look at the location of the design, the proposed design. So for this design, we are placing our SeniMal in Kota Baru Parahyangan, which is roughly in the distance between Jakarta and Bandung. And on top of that, there's actually an infrastructure development in the form of a high-speed railway that will be developed by 2022. And therefore, this absence will help the function of the building, where it can encourage pedestrians to come there or by using public transportation. Next. So as we can see, the train will actually stop by Padalarang Station, which is only about 5.4 kilometers distance from Kota Baru Parahyangan or the site. And this distance is actually travelable by bus or by car in only a 10-minute distance. And we hope that by encouraging pedestrians here or maybe a public transportation system, this design can develop well and encourage the districts around it to increase its education and also its art performance. Next. So the basic overview of our design is that the design is hoped to encourage the public to explore a recreational spot that also educates its visitors and local art. It is located in a new settlement in Kota Baru Parahyangan, where SeniMal will complete the local requirement of an art center and exhibition, as well as a public green space. Through a pedestrian-friendly development, SeniMal encourages visitors to use public transportation or bicycle to help its goal of reducing carbon emission. SeniMal is also equipped with several functions, such as an indoor hall, an outdoor amphitheater, workshops, and an art studio, art gallery and expo, as well as food court and commercial space. Next, please. So the basic concept is actually just a combination of these three main ideas, where the design hopes to encourage its visitors to explore the area, and the design itself helps to connect between programs, and therefore it creates a reaction of hopefully them becoming educated or interested in the local arts. Next. So now we go into the design and how we respond that from what we find in the surrounding. Next, please. So this is the basic site plan of the design. As you can see, the design actually has very minimal entrance for motorized vehicles, which is seen on the furthest right side, where it's only one single loop to function as a drop-off, whereas everything else can only be reached by pedestrian or by walkways. Next. This is the project data. Next. So this is how we look into the design and how we develop it. So first of all, we look at its setbacks from each side, and then we get a basic form of how we can develop this design. Next. From there, we try to create a mass, and in this instance, we create two masses, one on its upper side, on its northern side, as well as on our southern side, where its shape is a response towards the globe, towards the sun path. Next. On top of that, we create a connection through presenting a drop-off that also functions as a sky bridge to connect between the southern and the northern designs, as well as providing an outdoor amphitheater on the furthest western side. Next. And we get our final design, which roughly looks like this. Next. So for its program, it's, as said before, it mainly consists of public, office, exhibition, and educational, as well as commercial, where the southern building is mainly used for public, whereas the northern side is used for semi-private or for educational purposes. Next. Okay, next. We can go through this. Next, please. And next. Okay, next, thank you. So this is a rough overview of how we try to develop the design. First of all, we try to maintain its terrain, try to maintain its contour as it is. So we try to implement the design with minimal changes or minimal reconstruction of the site, where we use the topography to actually present our amphitheater on the outdoor, which is provided on the furthest left side of this diagram. Next. As you can see, it's also implemented in its other section, where the left side of the building is actually slightly higher than the southern side of the building. And because of its mass, we also provide a single void in the middle of the southern building to increase light as well as ventilation. Next. This is also an overview of the amphitheater. So on that topography, we actually add some ramps as well as stairs to provide a landing for both pedestrians as well as disabled people if they want to view this. As well as you can see on the southern side or on the left side of the building, each level actually has a easy view towards the amphitheater, so that even if there's an exhibition going on there, people from the building can also be part of it. Next. So this is the strategies. My friend will take over. Thank you.
And this is our strategies to enhance the design to reach the net zero energy healthy building. Next, maybe. Yeah, we have 5 strategies. At first, is massing. At the beginning, we do the placement and mass on the site oriented towards wind flow and solar path. And the second, we design the facade. Implementation of building facade to maximize lighting and airflow. Then we choose low carbon footprint material, reducing material finishes and modular size application. And then we did active design through selection of low energy smart device. And the last one is, of course, renewable energy, utilization of abundant natural energy in Indonesia, such as wind and sunlight. Next. Yeah. As you can see that this is wind velocity on the side. The average wind velocity outside the building is on range 0.5 to 0.8 meter per second, which is indicated by the number of green to blue color, indicating that the thermal comfort outside the building is categorized as comfortable. Next. And then we did the facade design. Padalarang have a climate that tends to be hot and humid, encouraged the design of a facade that respond to the slope of the winter solstice and summer solstice, so that heat can be reduced and wind can be maximized to push humidity from the inside to the outside building. As you can see as the diagram on the right, winter solstice north, the altitude is 59.71 degrees, and the summer solstice south, altitude is 73.43 degrees. Next. As you can see at the section degrees, most of the space are open, and certain space that require enclosed space like office leasing space and kitchen and maybe library. We provide with sufficient ventilation through narrow windows and sliding windows. And this is our wind, next, maybe. And this is our wind velocity simulation inside the building. Based on the diagram, average wind velocity speed which pass through the building is on range 0.56 to 1.2 meter per second. Next. Yeah. From facade design, we did the simulation with typical modular grid building, and within 8 a.m. to 4 p.m., average looks with daylight is about a range or about 260 looks, and it meets the requirement most of the spaces, except certain spaces that require high minimum looks level, like library, offices, kitchen, and handicraft room. And that's the simulation we use by Dialux from 8 p.m. to 12 o'clock. Next. Yeah, this 2 p.m. and 4 p.m. Next, thank you.
So this is our LCA calculation. Next. Next. So after we design the passive design strategies, we maximize our energy efficiency by using smart devices strategies. As we can see from the table, we try to specify each room requirements, and then we use the smart devices to accommodate the needs. As we can see from the side, the wind speed is low, so we achieve thermal comfort by using large low-speed fans, and we use air conditioner for specific rooms such as recording room and auditorium room, which needs to use VRV as well. And next. And for the lux requirements, we adjust by using the appropriate number of lamps so that it can provide the activity of each rooms. And for the vertical circulation, SeniMal uses stairs as its main vertical circulation, but we also provide energy efficient lifts for disabled so that the design can be more inclusive. Adding up the energy from all the lists above, SeniMal building energy consumption is about 457 kilowatt hour per day. Next. To provide the energy requirements, we use solar energy, solar panel for its alternative energy source. So we use helioscope for the installation simulation, and we use the data from Global Atlas, and we iterate the degrees so that we can have a conclusion that 7 degrees is the best degree to maximize its energy intake. From this renewable energy installation, we can have about 174 kilowatt hour per year. Next. For rain harvesting, we have 2 scenarios, which is the high density rain scenario, which it provides 728.75, which from the low density rain scenario, it only provides 45% of the needs. Next. And for vegetation, we use monkeypot tree for the wind barrier, and Madagascar almond for pedestrian shading, Kogon grass for pedestrian barrier, and Brazilian wild tree for void vegetation. Next. Next.
Hello. Okay, so from here, I guess we would like to look at the design expression. So next, please. So for the first view here, we provide you the drop-off entrance, where the drop-off actually is in a form of a sky path or a skywalk. However, the form itself becomes a coverage for the drop-off and therefore becomes an interaction space as well as an inviting space. Next. From here, we can see from on top of that bridge that the middle corridor of the area is actually provided by lush vegetations as well as some or several vertical axes wind turbines, and that therefore can also provide some renewable energy towards the design. Next. Okay, from here we can see it from the perspective design, from the pedestrian perspective, how this whole entire integration of the lush design helps the pedestrian area to become more inviting. Next. Okay, next. So this is also the view from the void. As previously mentioned, this area helps for increased sunlight as well as ventilation, and therefore we also provide some vegetations here. Next. This is the view for the outdoor amphitheater. And as you can see, the trees that we provide here have relatively higher tusks and position of the canopy that's slightly higher, and therefore provide a prolonged view towards the amphitheater. Next. And this is also another scenario for the amphitheater. And next. And that would be all from us. Thank you very much for your attention.